Hello and welcome to our last lesson. We want to start to look at the big picture of all the information about spreads and measures of center and how skewing affects how we might try to interpret, as well as if we have normal or symmetric. Um, if the data is skewed, what we're going to want to use is the median for the measure of center, and we look at the IQR for our spread. In this situation, the data will be less affected by extreme values for the median. Likewise, if the data is symmetric or normal, normal is really what we want to look at, the mean is a good measure of center, and standard deviation will measure our spread. In this situation, the mean will be more affected by the extreme values. So if there are extreme values, we tend to like the median and IQR. If it's more symmetric or bell curve, we like the mean and standard deviation. So we're going to do a bit of a review here with some material from our opener. Pretend for a moment that our tests are out of 100 points and there's a dot plot of our class's scores. The mean of this data distribution is 80 and the standard deviation is 10. We've got that information down here. We want to describe the shape of this distribution. If you look at it, it really looks like a normal distribution. Certainly not skewed in this sense. It is pretty spread out though. If we wanted to make a box and whisker plot, we could go to the median, the min and the max, the minimum being 60, the max being 99 up here somewhere, and then Q1 at 76 and Q3 at 84 and a half. And when we look at it in a box and whisker, it should look relatively normal. We'd be tempted to use the mean and standard deviation in that case. But if you'll notice, our median and mean ended up the same. That's not surprising. If there were 3 students that didn't take the test and they were scored as a 0, the addition of these 3 data points affects the distribution in what ways? So we want to try to determine for the shape, it's going to skew it left. It's going to put a bunch of numbers way down here. The center, the mean would be significantly affected, but the median less affected if, again, we added these extreme values, and that relates to our first slide. The spread, it's going to make it much more spread out because we're going down to a 0 in that case. And if we, based on this new shape, which summary statistics would be more appropriate to use? Well, in this case, it would make more sense to use our median. And then for our spread, we would use the range. It's really spread out. We want to make that clear. Looking at some classwork that we had. How many, let's say, consider the histogram of black cherry trees. These are going to be the heights, and this is the frequency. How many trees we found in this bin width of 5. So how many trees are part of this data set? Well, it's going to take a little time. We got to count up what we have. Now, I suggest that you put at the top of the bar graph, or sorry, histogram. It's not a bar graph. It's not categories. So if we add all this information up, let's see here, we got 6, 8, 16, 26, 31, it looks like. How many trees are less than 75 feet tall? That's going to be the sum of these numbers here, and that's 14, it looks like. Describe the shape of this distribution. This is relatively normal or symmetric. Certainly don't have any extreme outliers. There's no spaces in between these. The park rangers recently planted 2 new black cherries, and they're under 15 feet, so they're going to be way down here if we could see them. If they were included, describe how each summary statistic measure would change. Well, the range would change a lot. The mean, because we'd be adding in those numbers, would change by a lot. The median less changed, and the standard deviation in this case, we'd be less inclined to use that type of data, but that would be less affected. The shape would be significantly, it would become a left skew graph. Probably use a box and whisker. And which would be greater, the mean or the median? Because we're adding an extreme value, a bunch of extreme values that are on the low end, the mean is significantly brought down. So our median would be a greater value. It would cross out those low values and end up more in this range. But the mean would be greatly affected. If Robin is a server at a restaurant, and this box plot shows a distribution of 60 tips for 1 day of work, what percent of her tips were over $4.50? Well, here's 450 here. These are broken into quartiles, so 25% are above that. Did she earn more tips between $1 to $3? This area here, which is 50%, or from 3 to 9, which is also 50%. So kind of a trick question. They are the same. Describe the shape of this distribution. This shape, it looks like it's more of a right skew, and that makes some sense because we have that extreme value. In fact, what looks like an outlier up here. If one of her tips that was counted as $2 was actually supposed to be $20, so that would be even further out to the right. Describe how each summary statistic measure would change. So the range would change a great deal. It would go from 8, 1 to 9. It would go up to 1 to 20, 19. The mean would be much greater. The median, less affected. So in fact, it basically, we'd cross out 2 on the top and 2 on the bottom. It was 60 data points, that's a lot in there. We're still going to be basically not affected on the median. Standard deviation, in this case, it would be affected. In this case, our standard deviation will be affected somewhat, we'll say. Okay. And then the shape, it would be even more of a right skew. And then which would be greater, the mean or the median? The mean now is going to get dragged up very high. So in the previous example, the median was greater because it wasn't affected. In this case, the mean is affected because it's greatly affected by larger values. And that covers pretty much everything we want to get through. Hopefully this is making some sense and we can talk in class.